Now discuss about the remainder theorem. Let's see.
The long division method is the method of dividing a polynomial px by another polynomial gx, where the degree of px is greater than or equal to that of gx and gx is not equal to 0. As in the case of the division of whole numbers, where we obtain a remainder and a quotient, in the division of polynomials too, we obtain a polynomial Rx, which is the remainder, and a polynomial Qx, which is the quotient. Here, Rx is either 0 or a polynomial of degree less than the degree of Gx. So, Px is equal to Qx Gx plus Rx, where Px is the dividend, Gx is the divisor, Qx is the quotient, and Rx is the remainder. Let's divide Px is equal to 2x plus 3x square plus 1 by Gx is equal to 2 plus x. Step 1. Arrange the terms of the polynomials in the descending powers of x. Px is equal to 3x square plus 2x plus 1. Gx is equal to x plus 2. Step 2. Divide the first term of the dividend by the first term of the divisor. The result is the first term of the quotient. The first term of 3x square plus 2x plus 1 is 3x square, and the first term of x plus 2 is x. Divide x square by x, we get 3x square by x is equal to 3x. So 3x is the first term of the quotient. Step 3. Multiply the first term of the quotient obtained in step 2 by the divisor and subtract the product from the dividend. The result is the remainder. Multiplying x plus 2 by 3x, we get 3x, x plus 2, is equal to 3x square plus 6x. Subtracting 3x square plus 6x from 3x square plus 2x plus 1, we get remainder is equal to 3x square minus 3x square plus 2x minus 6x plus 1 is equal to negative 4x plus 1. The remainder is negative 4x plus 1. Step 4. If the degree of the remainder is less than the degree of the divisor, then no further steps are required. However, if the degree of the remainder is not less than the degree of the divisor, then consider the remainder obtained in step 3 as the new dividend. The divisor remains the same. Repeat step 2 and step 3. The remainder obtained in step 3 is negative 4x plus 1. The degree of the remainder is 1, which is equal to the degree of the divisor. Therefore, considering negative 4x plus 1 as the new dividend, we will continue with step 2 and step 3. Dividing the first term of this new dividend by the first term of the divisor, we get negative 4x by x is equal to negative 4. This is the second term of the quotient. Multiply negative 4, we get negative 4x plus 2 is equal to negative 4x minus 8. Subtracting this product from negative 4x plus 1, we get 9. Therefore, 9 is the remainder and 3x minus 4 is the quotient. We can check if the quotient and remainder are correct by replacing them in the equation. We see that the RHS and LHS are equal. Thus, our quotient and remainder are correct. Let Px be a polynomial of degree greater than or equal to 1, and x minus a be a linear polynomial, where a is a real number. If Px is divided by x minus a, then Pa is the remainder. Let's look at the proof of this statement. Let Px be a polynomial of degree greater than or equal to 1. Px is divided by x minus a, let the quotient be qx and the remainder be rx. So, Px is equal to x minus a, qx plus rx. We can see that the degree of x minus a is 1. This means rx is a constant term, say r. In other words, for every value of x, rx is equal to r. So, if x is equal to a, then Pa is equal to a minus a, qa plus r is equal to 0 plus r is equal to r. Hence, Pa is the remainder where a is the 0 of the divisor polynomial. Tap the divisor polynomials to see the zeros and the remainders. Tap the buttons to understand this better with more examples. Fill in the blanks with the correct options. Fill in the blanks with the correct options. Fill in the blanks with the correct options. Fill in the blanks with the correct values. 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 Let's summarize what we have learned in this topic.